Hi viewers, how are you all? Hope everybody seems to be safe. Okay, in the previous session we have discussed regarding the resistors when they are connected in series and parallel combination, and even when they are combined on both the likewise in series and parallel connection, and even we have seen some numericals based on the circuits. And in this today's session we are going to learn about the Kirchhoff's laws in electric current. How many laws are there? Okay, then why late? This is Santhosh Kumar. Welcome to my channel, Sims Academy. Actually, how many Kirchhoff's laws are there? Okay, let us write them initially. Some people spell it as Kirchhoff's laws. Actually, C and H have been silent. We spell it as Kirchhoff's law. We have two laws. Number one, current law or junction law. Second one, voltage law or loop law. Two laws given by Kirchhoff's. One law is current law or junction law, and second one is voltage law or loop law. Okay, let us go for the first one. First one is Kirchhoff's current law or junction law. Now, first of all, we should learn what is a junction. A junction is a place where three or more lines meet, three or more roads meet in our daily life. Yes, three or more. Similarly, here a junction is a place where the going or coming, whatever it might be, in a given circuit, the currents, those are moving away from a point or coming towards a point. That particular point is called as a junction, or in other words, we say it as the point of concurrency of different currents in a circuit can be called as a junction. Okay, what does he give in this junction law? Junction law, Kirchhoff's junction law states that the algebraic sum of the currents at any junction in a circuit is always 0. What does this word algebraic mean? Algebraic in the sense we have to take the sign conventions. Suppose the currents are coming towards the junction. If we suppose that they are taken as positive, then the currents which are moving away from the junction, we consider them as negative. Hence, those who are coming towards the junction are positive, those who are moving away from the junction are negative. When we add all those things, positive and negative, whatever it might be, we say it as the algebraic sum. Or in other words, we can even state this Kirchhoff's junction law or current law as the sum of the currents which are approaching the junction or coming towards the junction are equal to the sum of the currents which are leaving the junction or moving away from the junction. Let us see here. This is the junction where we have few currents which are coming inside and which are coming outside. Okay, I1, I2, I3, I4, I5 and I6 in a circuit at a particular junction. We have a total of 6 currents, namely I1, I2, I3, I4, I5 and I6. How many currents are coming towards the junction? Okay, I1, I2, I think I4 as well, and next I6, that equals to the sum of the currents leaving the junction. What are the currents those are leaving the junction? Here, I3 and I5. This is about the Kirchhoff's current law or junction law. The algebraic sum of the currents at any junction is always equal to 0. Algebraic sum. Let us bring those things to this side. I1 plus I2 minus I3 plus I4 minus I5 plus I6 equals to 0. This is about the Kirchhoff's junction law. Let us take a small numerical based on this. We may be asked sometimes like this. We are given some currents. This is 2 amperes, this is 4 amperes, this is 5 amperes, and this is we have 6 amperes. Now, using junction law, we are asked to find I, the unknown current value, using junction law or current law. How to find now? The same one. The sum of the currents which are coming towards the junction is equal to the sum of the currents leaving the junction. Okay, what are the currents here coming towards the junction? Number one is I. No. Yeah. Plus 6 equals to leaving the junction. 2 plus 4 plus 5. I plus 6 equals to 2 plus 4, 6 plus 5, 11. I equals to 11 minus 6. It is 5 amperes of current. Here I equals to 5 amperes. This is the application of Kirchhoff's current law or junction law. What does it state? It states that the algebraic sum of the currents at any junction is always 0. Or in other words, we can write it as the sum of the currents which are coming towards the junction is equal to the sum of the currents which are leaving or moving away from the junction. Now, let us go on a discussion with the Kirchhoff's voltage law or loop law. Voltage law, before going to that, let us get back to the Ohm's law. Its mathematical representation is V equals to IR. The mathematical representation of Ohm's law is V equals to IR. V represents the voltage, I represents the current, and R represents the resistance of the given resistor. Okay, now what is voltage law? Generally, Kirchhoff's voltage law or loop law states that the algebraic sum of the increase or decrease in voltages, or else we even say them as potential differences, in a closed circuit, closed loop, is always 0. Okay, as I told you, algebraic means when we go in this way we take it as positive, in other way we take it as negative. Now, to apply this Kirchhoff's voltage law or loop law, we need to learn about some sign conventions. How to learn them? Okay, what are the things those are involved in this? Let us see. Let us take a simple circuit where it consists of a cell, a switch, a resistor. As we know, resistor R, okay? As we know, the current always flows from the positive terminal of a battery to the negative terminal. let the cell creates a potential difference of V volts in the circuit. Okay, now where it produces a current of I amperes. Now, what are the sign conventions we have to take? Sign conventions in case of Kircchoff's voltage law. Either we move in clockwise direction or in the anti-clockwise direction, whatever it might be. These sign conventions hold good always. Number one, in a battery, in a cell or a battery, when we move from negative to positive, V is considered as positive. From where we have come is not important, to where we have gone is very important. In a cell or a battery, from where we are coming is not at all valid or important here. To where we have gone. I have moved from negative terminal to positive terminal of a battery. Then I should take the voltage as positive. Suppose if I move from positive terminal to negative terminal of a battery, then I should consider the voltage as negative. To where I have come here? To negative. To where I have come in the first case? Positive. Hence V is taken as positive in the first one and it is negative in the second case respectively. Now what about the current? If we move along the direction of current, then current is taken as negative. If we move opposite to the direction of current, then current is considered as positive. We have four conventions. We have come here. To where we have gone is important in case of voltage. If we are considering, if I come to positive terminal, then voltage must be taken as positive. If I come to negative terminal, voltage must be taken as negative. If we move along the direction of electric current, current must be considered as negative. If we move opposite to the direction of electric current, current must be considered as positive. Okay, let us apply that one here in the very small circuit. We shall move in the clockwise direction. If I move in the clockwise direction here, this is the way. Let us start from the cell here. We are moving from like this, we are moving in the clockwise direction. I have come to positive from negative. To where I have come here? Positive. Hence, voltage must be taken as positive. Now I shall move on to the resistor. What is the potential difference across the resistor? Now coming to Ohm's law, what is the voltage across the resistor? V equals to I into R. The current into the corresponding resistance. Here the resistance is R and the current is I. In the sense V equals to IR. The potential difference across this resistor is I into R according to the Ohm's law. Hence, we are moving along the direction of electric current. When we are moving along the direction of electric current, we take current as negative. V minus IR equals to 0. Okay. You may ask me the question, sir, what happens if we move in the anti-clockwise direction? Nothing happens, but the answer remains the same. Let us see if we move in the anti-clockwise direction here. Let us start from the cell itself. To where I have come, like this, I am moving anti-clockwise. To where I have come to negative terminal of the battery. In the sense, voltage must be taken as negative. I am moving opposite to the direction of electric current. Current is negative. That means what is the potential difference across this resistor? Obviously, according to Ohm's law, it is IR. But what is the sign we need to give for that? Negative or positive? We are moving opposite to the direction of electric current. Opposite to the direction of electric current, current is positive. Hence, minus V plus IR equals to 0. If I multiply this entire equation with negative sign, I get the same thing. V minus IR equals to 0. I hope you understood. Let us take a simple circuit, another circuit which consists of two cells. Now we have taken two cells. Let its voltage be V1, V2. It causes a current of I2. This is the resistor R2. And similarly, this is the current I1, resistor R1. In which direction we shall move? We can move in any direction, okay? We shall go on in clockwise direction, clock in the sense like this. We have to come from this side. Let us start with V2, to where we have come to positive. In the sense, V2 is positive. Now coming to electric current, we are moving along the direction of electric current. I is negative. What is the potential difference across the resistor R2 according to Ohm's law? V equals to IR, V2 equals to I2 R2. But we are moving along the direction of electric current, hence current is negative. Then the potential difference across that resistor is I2 R2. Okay, we keep on moving like this. So this is I1 coming out here. Now we are moving opposite to the direction of electric current I1. When we move opposite to the direction, I should be taken as positive. I is positive, hence I1 R1 is positive. And coming to the cell over here, voltage, to where we are going? No, to where I have come here to negative. That means minus V1 equals to 0. This is about the Kirchhoff's voltage law or loop law, and these are the sign conventions. Sign conventions needed to be kept in our mind compulsorily when we move from negative terminal of a battery or a cell to its positive terminal. To where we have come is very important. Voltage should be considered as positive. If I move from positive terminal of a cell or a battery to the positive to negative, to where I have come is very important. Voltage is taken as negative. If I move along the direction of electric current, current should be taken as negative. If I move opposite to the direction of electric current, current must be taken as positive. Okay guys, I hope you people understand well about these Kirchhoff's laws. There are two laws. One is current law and second one current law or junction law. The second one is voltage law or loop law. And hope this is the part 4 of electric current. We are left with electrical energy and electric power, which we are gonna discuss in the part 5. And this is Santhosh Kumar from Sims Academy signing off.